All right, this is the big part of 8.4, is actually looking at how you can take a word problem and you can use matrices to solve it. So your first step for all of these is to actually define your variables. So I'm going to read through this. It says an apartment building has 50 units. All are 1 or 2 bedroom units. 1 bedroom units rent for $425 per month, and 2 bedroom units rent for $550 per month. That's a steal, guys. That's not accurate as to today's times. When all the units are occupied, the total monthly income is $25,000. How many apartments of each type are there? So if you find your question, that's where I want you to start. So I'm going to highlight that in purple right now. The question is going to tell you what to define the variable as. So we have how many of each type of apartment. So this one, it's a little hard to use unique letters, so I'm just going to stick with X and Y. But if you were talking about like roses and tulips and you wanted to use R and T, you could. So for this one, I'm going to do X is going to be, I'm going to be very specific here, the number of 1-bedroom apartments. And Y is going to be the number of, because that's what they're asking us to find. It says how many. The number of 2-bedroom apartments. So then from there, because it's 2 variables we're trying to find, I know I have to write 2 equations to be able to solve this system. So you're breaking down the different information given to you into categories and into groups so that you can group things together to write an equation. So the first thing that pops out to me is we have money, and they told us the amount of money for each type of unit. All of those are going to combine together to make one equation. So I know the 425 goes with the 1-bedroom units, which we called X. So it's going to be 425 times X. And then if I add that on with 550 goes with the 2 bedrooms, which we called Y. That together, the total income for all of those has to be $25,000. So that's one equation. We know we need a second equation because you have to have 2 to solve for. So you have to look for the other important piece of information they're giving you so you can get a second equation. That other important piece of information is that there are 50 units. That is a total number. They're giving you that is total how many there are. So that just means that X plus Y has to equal 50. Okay, so hopefully you see where those 2 equations came from. The rest of this is just what we learned yesterday. Is the next thing you're going to do is set up your matrices here. We're going to do the coefficient matrix first. Then we're going to do the variable matrix, X and Y. And then we're going to do the answer matrix. And then we're trying to get to solve for X and Y. So we need to take this guy and move it to the other side. To move it to the other side, we're going to have to use the inverse. So you're going to type in your calculator the inverse of that times the answer that was on the other side. And then that's what should pop up on the calculator. Notice these are whole numbers. Because of the setup of this problem, we're talking about the number of units. That has to be a whole number. You do need to keep that in mind for the type of problem you're doing. There are some instances where you could have a decimal answer if we were talking about how much money something cost. But just make sure that your answer that you're getting seems legit, that it is the type of number that you should get for that kind of answer. So the last thing I want you to do here, because this is a real world problem, is I want you to answer the question in words. So you need to explain what the 20 and what the 30 mean here, and that we're just going to look back at what we called the variables. That means we have 20 1-bedroom apartments and 30 2-bedroom apartments. So you just have to answer explaining what those answers you got are in reference to the problem. Let's try another one. All right, so example number 2, Bill's restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. How many of each type of flower was ordered? So let's again start by defining our variables. So we want to know how many of each type of flower. So this one has 3 different types, and this one I would use the letters that are there. So C is going to be the number of carnations. R is going to be the number of roses, and D is going to stand for the number of daisies. And we're going to start to pick apart the information we can group together. Again, the first thing that pops out to me is all of these money numbers. Those are all going to appear in one of our equations. Notice this time we have 3 variables, so we have to make 3 equations. So first equation is 150C, 150 or $1.50 for carnations, and then 5.75 R for roses, and 2.60 for D. That has to equal 589.50. If you want to drop the zeros off on the ones that have zeros, you can. That's fine. Another easy number to deal with is the total number of flowers up here. So we know that they ordered 200 flowers altogether. So that's going to tell me that C plus R plus D, all of the flowers added together, has to equal 200. That's our total number. And then there's one other thing they told us that's important, and this is the one we got to think about a little bit how to make this happen. So they ordered mostly carnations. That's really not a mathy thing that we can work with. We do know that that should be the biggest number when we do this in a second, but this gives us something mathy we can do. There are 20 fewer roses than daisies. So to set something up with that, I really have to think about it. What I like to think about is just making up a number for the possible number of daisies there could be, or the number of roses there can be. So I'm just going to imagine, this isn't necessarily true, but I'm going to imagine, let's say that there were 10 roses. If there were 10 roses, then if I read this statement, let's see what this says here. It says that there are 20 fewer roses than daisies. So the roses are actually the lesser number according to that statement. The daisies would have more. So there would actually be 30 daisies then. So then you can use this, just if you pick random numbers, to help you think about what this equation has to look like. So it should be, to get those to be equal, I would have to take the roses and add 20 to make it equal to the daisies. That's one way of setting it up. Or you could go with the daisies minus the roses has to equal 20. Either way, you have to set it up, and now we need to make sure when we go to plug this in that we plug them in the correct order. The R was first, so it'd be negative R plus D has to equal 20. Okay? And then we're going to go ahead and write our matrices out. This is going to be 1.5 plus, not plus, whoop, and then 5.75, 2.60, and then the next row is 1, 1, 1. In the bottom row, be careful, there's no C, so it's going to be 0, negative 1, 1, and then that's going to give me CRD equal to 589.50, 220. Then to solve this, I know I have to move this guy to the other side, I have to do the inverse of that times the other one. So that's what I'm going to do on the calculator now. So then over to the right there, you see what the calculator spits out. Those are nice whole numbers, which makes sense for this particular problem because we should be getting whole number answers since we're talking about number of flowers. So we're just going to change that again into what those actually go with. The 80 was C because that was the first letter, so that's carnations. So there are 80 carnations. And then the 50 was the second letter, which was R, so there's 50 roses. And then the 70 goes with D, there's 70 daisies. And what I like to do at the end is, especially that teal statement that was up there, that one that we had to really think about, is make sure that that makes sense with your answer. Are there 20 fewer roses than daisies? Well, there's 50 roses and 70 daisies, so yes, that did work out. Okay, we got one more. So this last one talks about puppy chow. It is made of rice cereal squares, chocolate and peanut butter, if you didn't know, and lots of powdered sugar. 1 pound of rice cereal costs $1.50 and has 1,700 calories. 1 pound of chocolate costs $2 and has 2,200 calories, and 1 pound of peanut butter costs $3 and has 2,600 calories. The resulting puppy chow weighs 9 pounds, costs $18, and has 18,600 calories. How much rice cereal, chocolate, and peanut butter were used? So step 1, define our variables. Find your question. That is telling you all of your variables right now. So we know we're doing rice cereal. So I'm going to say R is going to be, it says how much. So you have to think about what we're measuring in right now. This time we're not measuring in just a number, but we're measuring these in pounds. That's what all of this refers to. So it's going to be the number of pounds of rice cereal. Oops. And then the next one we have is chocolate, so I'm going to call that C. C is the number of pounds of chocolate. And then the last one for peanut butter, I'm just going to use P, number of pounds of peanut butter. So that's 3 variables, so now I'm expecting there's 3 different equations I can write. So again, I like to look at grouping stuff. Let's do the money stuff right away. We know all of those from the last 2 examples have to go together. So the 150 goes with the rice cereal, so that's 1.5 R. And then the $2 goes with the chocolate, so that's 2C. And then the $3 goes with the peanut butter, so that's 3P, and that has to equal $18. I just dropped off the extra zeros so we don't have to worry about writing those out a lot of times and then typing them into the calculator because the calculator is just going to drop them. All right, the next thing we know is there's actually another set of numbers that all talk about the same thing. There's all these numbers that talk about calories. So I'm going to put all those calories numbers together. So that's going to be 1,700 for the rice cereal, 2,200 for the chocolate, and 2,600 for the peanut butter, and the resulting total is 18,600 calories. But I know I need a third equation, so I need to look through the rest of the problem and see if I can get to pop out what the other number is. There's only one other number in the problem here, and that's the resulting weight. The resulting weight is 9 pounds, so that's everything together is going to equal 9 pounds. This guy right here is our total number. To get the total, we just have to add up R plus C plus P. That's why I was very specific about measuring those in pounds. Those pounds added together have to equal 9. Okay? So now let's go ahead and set up our matrix. It's going to be 1.523, 1,700, 2,200, 2,600, and then the bottom one is just 111. That's in the order CRCP. That's important, so when we get the answer, we know what order it's in. And then it's 18,600, and 9. So now I know to solve this, same setup we've been doing now these last 2 lessons, is I need to do the inverse of this guy to move him to the other side, times the one that's on the right. So I typed that in the calculator, and that is what I got. And then we're just going to relate that to what each of those numbers mean for our problem right now. So remember we were measuring in pounds, so this is going to tell me that there are 4 pounds of rice cereal, that there are 3 pounds, the next number was C, so that's chocolate, and the last number is 2, and that was measuring the amount of peanut butter. Now this example would be one where a decimal wouldn't be bad because you could have a decimal number of pounds. So if we got like a 1.5 or even a weird decimal, that would be okay because we're talking about pounds, and pounds can be a decimal. Okay? So there is one problem for you to try on ClassKick, and then you have, I shortened the assignment, I think there's 6 of them for you to try for homework. I just need you guys thinking in this way because this is an important problem-solving way of thinking. All right, have a great rest of your day. Have a great weekend, and go into tomorrow with an open mindset. You guys have a big advantage right now as you can get from a person really in the field that you're interested in, get some feedback from them. So just take advantage of that tomorrow. I know it's probably not ideally where you want to be, but there are a lot of opportunities for you to get questions answered and to get some insight into what you should be doing in your undergrad to approach the profession that you're interested in. So just really try and take advantage of tomorrow. Okay? You guys hang in there and stay safe.